An ice cream cone has a height of 4 inches and the radius of 1 inch. If the cone is 0.1 thick, what is the difference between the volume of the cone, including the shell, and the volume of the ice cream you can fit inside the shell? First, we draw a cone, including the shell. The radius is 1 and the height is 4 inches. We were told that the thickness of the cone is 0.1, and so if we were to use the cone to contain the ice cream, then the volume of the ice cream is a little bit less. And so how much less? That's the difference between the volume of the cone and the volume of the ice cream. The actual difference in the volume is the volume of the cone with radius 1 minus the volume of the ice cream, which is 1 minus 0.1, because the thickness is 0.1. That is V of 1 minus V of 0.9, and that is the actual difference in the volume. But we are not going to compute the actual volume. We will estimate the difference volume, which is dV. We're looking for dV to estimate delta V. Delta V is the actual difference and dV is the approximate. This is the estimate of the difference. dy estimate delta y. And so to have dy or dv in this case, we start out with the volume. The volume of the cone is 1/3 pi r squared h. But h is fixed, and so we can write this as 1/3 pi r squared. H is 4. This gives us V equals 4/3 pi r squared. We cannot just plug in r equals 1, not yet, because we still need to have dv to show up. If we plug in r equals 1 at this point, we would just simply end up with a number, and that will not give us the differential. dv is 4/3 pi 2r, and don't forget dr after the derivative. This is 8 pi over 3r dr. But what is r? R is 1 in this case, so we plugged in 1 into r. For dr is the change in the radius. The radius goes from 1 inch to 0.9 inches. And so the radius is 1. The delta r or dr is negative 0.1. The ending radius minus the beginning radius, so this is negative 0.1. If we put this in a calculator, we will get approximately negative 0.837758, or just simply negative 0.8, and the unit is cubic inches. If we were to compute the volume when r equals 1, we will get pi over 3 times 1 squared times 4. And if we compute the volume when r is 0.9, we will get pi over 3, 0.9 squared, and the height is still 4. The difference between these two is 0.7958, which is roughly 0.8. The magnitude of the difference is the same, 0.8. And so even though this is a dv, which is not the actual delta v, it is close.